Okay, so this is part 2 of the 5.1 natural logarithmic functions and differentiation section. I'm just going to go right back into some examples. I have 2 more, and then I just have one little paper on the derivatives of absolute value natural logarithmic problems. So here's the first example. We want to take the derivative of the natural log of this function. It looks like there's a lot going on, so what we're going to do is just use our properties of logs to first split it up. So the natural log of x times x squared plus 1 squared plus the natural log of, and I'm gonna just change this, instead of square root, I'm gonna change it to raised to the 1/2 power. So 2x to the third minus 1 to the 1/2 power. We've got a product right here, which we can use our log properties to split up into a sum. I just kept this right side the same. Now we can still use our properties of logs and bring our exponents out into the front. And we can also even differentiate this part, since we know that the natural log of x equals 1 over x. So plus, I'm going to bring our 2 out in front. Natural log of x squared plus 1. Plus, bring our 1/2 out in front. Now we're going to treat this right here and this right here both as a u, which means that we're going to have to do some u substitutions. We'll work with the first one right here. So if u equals x squared plus 1, then u prime is going to equal 2x. So we've got 1 over x plus 2 times 2x over x squared plus 1. This is my u prime. This is my u. These 2's can cancel out. And now we'll do our second u substitution right here. So in this case, u equals 2x to the third minus 1. When you differentiate it, u prime equals 6x squared. So we're going to put our u prime on top and our u on the bottom. This 2 can reduce this 6 down to a 3. And so if we clean this up, we get 1 over x plus x over x squared plus 1 plus 3x squared over 2x cubed minus 1. And there's our derivative. So once again, for this one, we'll split it up using our properties of logs. And so first thing we can do is we can bring this 3 out in front of the natural log. So now we're just left with a quotient. We can split that up using our properties of logs. So it's actually going to be 3 bracket natural log of this is a difference of 2 squares. So this one can be broken up into x plus 1, x minus 1, minus, and once again we have another exponent that we can bring out into the front. Here we have a product, a natural log of a product, which means we can split it up using our properties. And so there would be our derivative. I even think that could have changed this natural log of x to a 1 over x and then had this term be 3 over x, but I've got to double check on that to make sure. I'll post up an annotation either confirming or disregarding what I just said about that. So for derivatives involving absolute value, if u is a differentiable function of x such that u does not equal 0, then the derivative of the natural log of the absolute value of u equals u prime over u. So here I just have 2 quick examples. This first one, our u is defined as cosine of x. So if we have some side work, u equals cosine x. U prime, the derivative of cosine x is negative sine x. So u prime is negative sine x over u, which is cosine x. And that just equals negative tangent x. Second example, here's our u value. So our u substitution, we're going to have u equal, in this case, it's going to be oh, well, first thing we should do is just split it up using our properties of logs. So that way it's easier to see what is what. So the derivative of the natural log of negative 1 plus sine x minus the natural log of 2 plus sine x. Now that we have this, we can actually do 2 u substitutions. So this will be a u and this will be a u. We'll work with this leftmost one first. So if u equals negative 1 plus sine x, u prime equals cosine x. Which means that this side over here will be u prime divided by u, which is negative 1 plus sine x. And then we have a minus sign, Now our second u substitution will be 2 plus sine x. U prime in this case equals cosine x. So that's going to be cosine x over 2 plus sine x. Now we could get a common denominator. So it looks like our common denominator will just be, looks like it'll just be this term times this term, which means that what the left side is missing is a 2 plus sine x, and what the right side is missing is a negative 1 plus sine x. So that leaves us with cosine x 2 plus sine x minus cosine x negative 1 plus sine x all over negative 1 plus sine x times 2 plus sine x. You can do some distributing up top, so you get 2 cosine x plus sine x cosine x minus, but in this case, since negative cosine x minus times a negative cosine x will actually be plus cosine x minus sine x cosine x. This is all just, I'm just distributing this cosine x to those two and this cosine x to these two. All over negative 1 plus sine x times 2 plus sine x. You can combine like terms up top, and your final derivative, you have 2 cosine x plus cosine x. That leaves you with 3 cosine x all over negative 1 plus sine x times 2 plus sine x. Hopefully these examples and absolute value stuff makes sense. Main thing I would just recommend is look for properties of logs that you could apply, like I forgot to do here from the start. And then just look for u substitutions and things that can simplify.